Good day everyone! In this video, we will discuss about trigonometric equations. Recall that when solving an equation, we try to determine the set of all values of the unknown variable that satisfy the equation. In this lesson, we will find the set of all angles in a given interval that satisfy a given equation involving circular functions. These are the strategies in solving trigonometric equations. Number 1, write the entire equation in terms of just one trigonometric expression such as sine or cosine. Number 2, use trigonometric identities if necessary. And number 3, if the equation involves a multiple of an angle such as sine 3 theta, then determine all possible values of theta. Note that trigonometric functions are periodic. Thus, trigonometric equations typically have infinitely many solutions. When solving for all solutions, one strategy is to first find all solutions in one period and generate these to determine all solutions in the set of real numbers. Let us consider this example. Solve the trigonometric equation sine squared x minus 1 equals 0. Our given is sine squared x minus 1 equals 0. Notice that sine squared x minus 1 represents difference of two squares. We can factor sine squared x minus 1 into sine x plus 1 quantity sine x minus 1 equals 0. Next, equate both factors by 0. So we will have sine x plus 1 equals 0 and the other factor is sine x minus 1 equals 0. Next, isolate positive 1 and negative 1 on the right side of the equation. So we will have sine x equals negative 1 and on the other one, we will have sine x equals 1. Using our knowledge about inverse trigonometric functions, we need to find an angle which will give sine a value of negative 1 and a value of positive 1. On the left side, we have x equals 3 pi over 2 and on the right side, we have x equals pi over 2. Meaning, if we will substitute 3 pi over 2 in x here, so we will have sine 3 pi over 2 which will be equal to negative 1. On the other hand, if we will substitute pi over 2 on x here, then we will have sine pi over 2 equals 1. Thus, the solutions are x equals pi over 2, 3 pi over 2. Let us have another example. Solve 2 cosine x equals 1 where x is in the range 0 to 2 pi. To solve our given 2 cosine x equals 1, let us isolate cosine x. Dividing both sides by 2, we will have cosine x equals 1/2. Our task here is to find all possible angles that we can substitute to x here, wherein the value of cosine will be equal to 1/2. Thus, the solutions are pi over 3 or 5 pi over 3. Let us have another one. Solve cosine 2x equals cosine x, where x is in the range 0 to 2 pi. Using the double angle identity, remember that cosine 2x is actually equal to 2 cosine squared x minus 1. Hence, our given equation, cosine 2x equals cosine x, will become 2 cosine squared x minus 1 equals cosine x. Write all the terms on the left side of our equation. We will have 2 cosine squared x minus cosine x minus 1 equals 0. This trinomial here can be factored. The factors will be 2 cosine x plus 1 quantity cosine x minus 1 equals 0. Next step, equate both factors by 0. So we will have 2 cosine x plus 1 equals 0 and cosine x minus 1 equals 0. Next, let us isolate cosine x on both factors. Thus, we will have cosine x equals negative 1/2 and cosine x equals 1. On both equations, we need to find the values of x, which are the angles that will give cosine a value of negative 1/2 and 1. For the left side, the angles that will give cosine a value of negative 1/2 are 2 pi over 3 and 4 pi over 3. On the other hand, the values of x or the angles that will give cosine a value of 1 are 0 and 2 pi. Therefore, the solutions of the equation are 0, 2 pi over 3, 4 pi over 3, and 2 pi. I hope that you have understood the lesson. This is the last lesson for Precalculus. I am hoping to see you again on our videos about basic calculus. Thank you so much for listening and see you on our next video.